The next section to take a look at fixing are the window frames. So if you connect your group unshared check to those frames, you can see once again we have lots of unshared edges in here. Looks like they're not all unshared, but if you zoom in real close, you can see that these window frames are planar surfaces and they just have these flat edges and it's not a closed mesh at all. Now because there are so many window frames, it can seem like a real project to fix all of these, and certainly it would be kind of crazy to fix those all by hand. But since each one of these window frames should be exactly identical, if we fix one of them, we can do that in a loop on all of them. So let's go back and just display the frames themselves. And since we have unique paths on each of these pieces, we can just grab any one of those and we'll hit delete and then flip that blast to delete non-selected. So we're just dealing with one window frame for now. Now first, let's start by extruding this flat edge backward so that we can build a nicer surface with some thickness. If you hit S for your selection, and we'll turn off this groups or connected geometry option and turn on your selection by edges, you can see you can grab those edges like so, and if you double click on that edge, it'll select that entire edge ring, and then tab in the viewport to create a poly extrude. Now that poly extrude is automatically set up with the edge selection that we selected in the viewport there, and we can just extrude that backwards a bit, maybe 063, like so, and unfortunately that looks like that's not going in the right direction. I often find with poly extrudes that the extrusion mode can be much more reliable if we set that to point normal. And you can see now that has all of this extrusion going in the correct direction. Now you might be able to tell already this is a little bit of a custom job on this one. It's not just a simple extrude and done, because this is much more complicated geometry. And this is where it's really valuable to get used to the various modeling operations available to you in Houdini. You can check the poly tools in the shelf if you'd like, or explore all the various nodes. All of these various poly operations could be handy for fixing various issues in geometry. But for now, I'm just going to manually bridge each of these edges to the opposite side. Now, in order to manually bridge each of these, you can once again go to your edge selection, and we're not going to select edge rings now, but you can just grab one of these edges and then tab, type bridge for poly bridge. If you hit enter, you can see this little hint in the viewport. It says now select the bridge destination polygons or edges and press enter to complete. So you can select the opposite side and hit enter, and you'll see that it creates this poly bridge for you here. Now this is creating it with 10 divisions. We can just set that down to one division just to make it one single polygon. And because we're going to do this repeatedly, you might find it a bit easier to set that as the default value. So I'll right click that and say make current value default. Now we don't have to bridge everything by hand. We can use a poly fill to fill in some of those, but I'm going to go in and add a few more to make that poly fill more reliable. And now that I've filled in these sort of horizontal patches, we can use the poly fill to fill in these vertical gaps that are still remaining there. So after these poly bridges, we'll just go in here, drop in a poly fill like so, and you can leave the poly fill with all of its default values, connect that up there, and you can see that fills in all those gaps there. Now there's one more little problem with this fixed geometry. You can see that the normals are kind of messed up and the display is pretty weird in some of these areas. And we can just fix that with a normal node. So you can drop it in like so. And now we're ready to run this processing on all of the window frames in a loop. So I'm just going to get rid of this unshared group check here, and we're going to create a for each loop. We'll do for each named primitive, and that will default to use the name attribute, but we want to loop over each unique path in this case. So on that for each end, just change the piece attribute to path. And if you display the for each begin, you can verify that it's just processing one window at a time. And then we can connect that for each begin to our setup starting with the poly extrude down through that normal at the end, which will connect to the for each end. And you can see this one window frame here is fixed in the same way as the original one was. Just line these up a bit more nicely. And then if we go to the end of that loop there and let it cook, you can see all of our window frames are nice and cleanly fixed. Now sometimes I like to put little fixes like this in their own subnets to keep the network clean. We can delete this blast node there, and I'll just select this whole fixing network and hit Shift-C to put it into a subnet. And I'll call this fix window frames. Now I believe I mentioned this in some earlier videos, but anytime you're working in a subnet, it's always good to add an output SOP to the very end. That will make sure that the correct result is ultimately output. If you don't use that and you have your display flag on something else, then whatever your display flag is on will be used as the final output. So you always want to use this to make sure it's kicking out the right thing. So now that all of our window frames are fixed, we can finally make sure that we have our name attribute set on all of those. We can just copy over that connectivity and naming wrangle node, and then go to that wrangle, and we'll set the prefix to just be window frame. So then if we display that final wrangle node and look at the spreadsheet, we can check our names, and sure enough, we have window frame 0 through 539.